And hello everyone, welcome back to this video series. So today we're going to continue our OpenFOAM series. Okay, and remember last video we were trying to do this sort of heat exchanger shape, and now I have a case set up in OpenFOAM which uses this shape, of course using Snappy Hex Mesh. And of course the mesh isn't like perfect, but it's decent. It holds the shape. There are some rough edges at the side. There are some rough edges at the side. But generally speaking, the way we would mesh our file, we would construct. The way we construct this case from scratch is very similar to the pipe case. Of course, this is actually more challenging than the pipe case because the shape is sort of more complex. And in fact, I ran into some issues. Actually trying to mesh it with Snappy Hex Mesh and using the Polydual Mesh utility, right? However, somehow it's running now. This case is running. I don't know if it's stable. I hope it is. The basic setup of the case can be quite straightforward. It's a bit tedious nonetheless, but it's nothing too different from what we are used to. Okay, so yeah, we can try to set up the case as what you are seeing here and set up the mesh. Okay, so we'll talk about the boundary conditions and everything. And one very interesting thing is when you see this mesh, it's not excuse me. Yeah, this mesh is not. This pipe actually, this inlet is not exactly facing the x-axis, y-axis, or z-axis, which means when we start to try and define our boundary conditions, alright, we try. Let's cd to here. Yeah, when we try to, let's say, do our boundary conditions, I'm going to just go to a random PimpoFoam file. For example, this one. I go to 0 original. I go to U, and you see normally where we'll have our boundary condition like so. We'll have this. For example, the inlet patch will be some fixed value, and the value you'll have to type in the velocity vector, the x, y, and z coordinates. Now that could be very troublesome, especially when this is really off center. As you can see, it's really off center. So you might want to prescribe another boundary condition just for this. So the boundary condition I would like to go with is this flow rate inlet velocity patch. Okay, as you can see here, there's no need to define any sort of boundary condition. No, you don't have to select the velocity vector that you want, the x, y, and z coordinate, but instead you use you prescribe a volumetric flow rate, and OpenFOAM will do the rest for you. So that's the one I would go with, and I kind of want to demonstrate that. So alright, I kind of have this case running. I still hope it's working, but I'm at least going to show you how to set up such a case. I don't know whether it's blowing up. My timestamp is getting smaller and smaller, but at the very least, show you roughly how to set it up so you can sort of play with it and stabilize it yourself. Alright, that's quite it. So I have a template file. Okay, this template file is okay. I can just do an all clean here. Alright, all clean. Oh, by the way, okay, never mind. I'll just do that later. Okay. So this case is the one I had with the tri-surface with a cylinder. Okay, and then you have this extended feature edge mesh. All of this is around. Alright, so all clean does not really get rid of this extended feature edge mesh, so that's nice. Alright, what we need to do instead, alright, what we are doing now is to roughly try and convert this standard pipe case into something that includes this geometry a little bit, and we'll try and move it from there. Along the way, I'll be showing some tips and tricks to help speed up your workflow. Alright, looks like my Quran number is starting to explode. Maybe it's not stable, but anyway, yeah, you probably have to sort out the mesh self by editing this pimple foam. Alright, otherwise the other way is to just make the mesh bigger. It usually helps with the stability for some reason. Okay, so anyway, let's start by doing this. We copy this template file into heat exchanger video tutorial. Okay, so I'll just demonstrate this. So heat exchanger video tutorial, and here is our mesh, so to speak. Okay, so first thing first, I want to copy over all the files. Alright, all the important files. And actually, what I've done in this Git folder, okay, what I've done in this Git folder is to include interesting shapes for you to play with, so you can play with your cases. One is the crude S-shaped pipe that I was talking about a few videos back. One is this heat exchanger here, and I can copy all of this, and let's go put it in our Snappy Hex Mesh and FreeCAD cases. This is the one I'm putting it in because we have all these complex shapes which are much harder to do than just a simple pipe, because we have to deal with FreeCAD and we have to deal with the meshing, and that's going to be harder. Okay, so let's go to Tri-Surface, put it all in Tri-Surface. Okay, so and let's change directory to this Tri-Surface. Alright, and what I want to do is remove the wall. Okay, I want to remove top patch, and I want to remove bottom patch, and begin cylinder star, because all of these I don't really need it anymore. Okay, so first thing first, alright, I'm gonna delete this, and maybe let me check this. Okay, yeah, this doesn't look good. Okay, the timestamp is getting smaller and smaller because I'm adjusting it for the Quran number. Apparently that's not working very well. But anyway, let's go through how to set up the case file. You can play the stability part later by changing the mesh and everything. Let's go to the heat exchanger tutorial. I'm going to try surface, and I'm going to just put the full heat exchanger object. So this is the full thing, the Tri-Surface file. And first thing I'm going to run is a block mesh. Okay, why run block mesh? Okay, I'm running block mesh so that I can compare the size of this file. So I'm going to run block mesh and touch block.foam. Alright, so I can open this up in ParaView. Now once I see that, I can roughly see where the blocks are oriented. So here you can see the blocks are not oriented very well. You can see the wireframe. Alright, a few things you can do. Let me start by making this block mesh bigger, because it's obviously way too small. Okay, let's see. Yeah, okay, this block mesh is actually way too small. So what can we do? We can change the block mesh dictionary. So I'm going to get out of this. Alright, and I want to change directory to the same folder, heat exchanger video tutorial. Let's VI system block mesh dict. Okay, so I can increase the scale, and I run block mesh again. Alright, and let's reload by pressing F5. So now this thing is way bigger, but a bit too big. In fact, in this Z direction is a little bit too big. So I can turn on the axis grid to see how big my block mesh should be. Alright, ideally I want it to go from minus 100 to 100 and going, that's in the Z direction. So let's change the Z coordinate so we can do it one at a time. Okay, so I'll change all of this to 1 because the scale is 100, right? The scale is 100. So minus 1 to 10 actually is minus 100 to 1000, as you're seeing over here. It multiplies by 100. So I'm not going to do that. I will have minus 1 to 1. So let's do block mesh again. And we'll just press F5 here to reload. Okay, so it's much smaller. This is what we want. However, I think it's a little bit too fine in the Z direction. I don't want it to, the block mesh to be so fine, as you can see here. So let's do that. System block mesh ticked. Let's put in the Z direction. I just want 5 points. 5 points. Okay, so and of course in the Y direction, I want the minimum Y coordinate to go to minus 400. Minus 400. Can you see here? It's at minus 100 now. It's a minus 100 now. Okay, it's a minus 100 now, but I want it to go to minus 400. So let's change that. So two things you want to change. I want to change the number of grids in the Z direction, number of cells. Then I also want to change this Y direction, not to minus 1 anymore, but to minus 4. So that this will be minus 400, the minimum Y coordinate. Okay. So let's do block mesh again, and we will just reload, and there you are. Everything is covered nicely. Okay, everything's covered nicely now, so we can move on to Snappy Hex Mesh. Okay, Snappy Hex Mesh. Alright, so let's clear both windows. Alright. Snappy Hex Mesh dictionary. So as you can see, I have to change all of this here. All of these object files. Okay, so as you can see, it's a little bit tedious. Okay, and not only have to do this, I also have to change this extended feature H mesh, because that's what I was using to do the objects there. So you can see it's a bit tedious. So if you are going for bigger and bigger files, it may be worthwhile to consider using learning another software such as Salome, where you have a GUI, a graphical user interface, and that's exactly what I am downloading at this point in time. Okay, Salome. Okay, OpenFOAM, and then you'll see this one, the Salome platform. All right, I mean a lot of it's a very popular. I've seen in the comments, it's very popular request. I was initially a bit reluctant to learn it, cause I thought Snappy Hex Mesh can do everything, but as you can see, Snappy Hex Mesh gets a little tedious, fairly tedious in fact, to do once you have many much more complicated shapes, and that can be quite a headache for us to run. Okay, so with that aside, let's start by changing these object files. Alright, I want to have this full heat exchanger object, so I'm just going to import everything here. Okay, so you see, changing these things one at a time. So inlet, okay, inlet, I'll save, and then I have an outlet. Outlet. Okay, so a few more. I'll need to paste maybe this too, and maybe I'll not type it again. I'll just copy and paste. It's much easier. Okay, so let's do inlet hemisphere and outlet hemisphere. So, and then there was one more called tubing. So let's do that. All right. Okay, so next one is to do in the tubing.obj. Okay, let me go to visual mode, yank and paste, yank, paste. So that's Y and P. So to enter visual mode, okay, I'm not gonna say this again. Okay, go and watch your own videos if you want to learn Vim. Alright, I've said this before. I've elaborated how to use Vim before, so at least the basics. So let's turn this to tubing. Alright, so that's part 1 of the Snappy X Mesh done. So this castellated mesh controls, I'm not going to do too much. This thing, I'm going to change it, the explicit feature edge refinement. Okay, so I'll need to change another dictionary. So it's surface feature extract dictionary. Instead of begin cylinder object, I need to change it to this full heat exchanger object. So let's do that. Okay, full heat exchanger object. So I can run surface feature extract. Alright, and that is done. Let's go to see in the tri-surface what file is added. It's a full heat exchanger.emesh. Okay, so this is the file I'll need to reference. System Snappy X Mesh dictionary. So this is the emesh file, extended feature, explicit feature mesh refinement. So this is the one we'll need to do. Okay. Alright, so we can make the refinement level a little bit higher here if we want. So maybe we'll put it what do we do? Yes, okay. We'll put it we'll try to okay. You know where this is? This is actually where your edges are. I mean this is where your edges are. They're between the pipe and this boundary, this surface here. All these sharp edges tend to need a little bit more refinement. So I'll just give it a little more refinement over here. So I'll give it a level 5 here. Okay, in case anything we need. Alright. So okay, I'm going to leave this cylinder file here as an example, but I'm going to need to type everything again. So instead of wall, I'll be using okay, I want to include several patches here. So what I'll do is, okay, I'll use this this method of doing it. So I have the tubing, and I have the inlet hemisphere, and I have the outlet hemisphere. So I want to try and like sort this thing out. I want to try and type it this way so that it's easier. I don't have to keep typing and typing and typing so many times. Right, so so this is basically for the tubing, inlet hemisphere and outlet hemisphere. I will have this sort of patch assignment. Okay, and the rest I'll just have an inlet and outlet. I hope this works for Snappy X Mesh. Alright, if it does, it will save a lot of time and effort. Alright, so outlet is here, and the rest don't really need to touch unless you know what you're doing. Okay, this one I will just say add 5 layers. Okay, I'll add 5 layers, and then I want to do it at the tubing. Alright, only at the tubing. I mean, I can do it at all the wall layers as well. I can do this, not an issue, but it will just take a little longer to run the iterations. Okay, so this is roughly what Snappy Hex Mesh should look like. Okay, don't expect everything to work from the outside. From the outset, you might have to do a little bit of debugging. Okay, but apparently this seems to work a little quite nicely. Okay, I'm pretty surprised there wasn't any sort of bugs or typos. Okay, so 9 seconds, 10 seconds is okay. So let me touch Snappy. Okay, I can use the block.foam to do that. Let's do block.foam and I'll press F5. This is the castellated mesh step because I didn't write the override. Didn't do the override. So let's put the next step is what do you call that? Next step is what's the castellated mesh. As you can see, near the edges, the features, these are refined pretty nicely. But like the pipes, they are really coarsely refined, a little too coarse. Maybe I should change it to a level 4. Okay, a level 4 refinement. So I'm gonna try changing it to a level 4 refinement. So this is probably what you do in your Snappy Hex Mesh workflow. System Snappy Hex Mesh Dictionary. Let's change it to a level 4 refinement. And yeah, surprisingly, I did not need to change this location in Mesh. But if it works, it works. I'm not complaining that it doesn't work. Because normally you would have to specify a point within this mesh, within this mesh here, alright, such that you're telling OpenFOAM or Snappy Hex Mesh, okay, I want to keep this part as the inside, and then you just delete the other parts. So okay, since that was not necessary, I won't go through that part. It just happens to work. If not, you have to like test roughly where the meshes are. 2, and let's get a level 4 refinement for let's get a level 4 refinement for here. And I'm almost out of time. Okay, so I'll delete all that. Now I'll run Snappy Hex Mesh one more time. Alright, run Snappy Hex Mesh one more time. So it should take longer. So I'm just gonna check these results and call it a day, so to speak. I hope this is working, and of course check mesh. I actually failed the mesh check. Okay, but alright, let's try anyway. We will deal with it in the future. You can see that at least the pipes in the middle actually are more well behaved and well shaped. So not too bad, but it's not the best since there are some illegal faces, as you can see here. And that's the thing about flying, going to Snappy Hex Mesh is like flying blind. You can't really see what's going on. It's all in command line. You can only see when you go to ParaView. So there may be some advantages, of course, to getting Salome getting familiar with Salome. The workflow is pretty simple, but that's another story for another time. So thanks for watching. I'll see you guys next time. We'll try to get this running the traditional Snappy Hex Mesh way. Otherwise, if this thing keeps getting stuck, we can try Salome. Okay, and then you'll learn more things. Thanks for watching. See you guys again. Bye bye.